The talk I wanted to do is a talk I've done many, many times before. It's called the Three Laws of Test-Driven Development, in which we are going to discuss the discipline of test-driven development, and I will also do a small demo, and I will use the Kotlin language for that demo. Three laws of TDD. What is test-driven development? Well, first and foremost, test-driven development is a discipline. And like all disciplines, it has arbitrary elements to it that many people might find frustrating or inexplicable. So, for example, surgeons, when they wash their hands before doing surgery, they do not simply walk into the scrub room and wash their hands the way you or I might. They have a discipline. They follow a ritual. And that ritual is fairly involved. For example, they might get a brush, and that brush they will use a certain kind of soap on. And then once the brush is soaped up and their hands are properly moistened, they will stroke their fingers 10 times on one side of the finger with the brush, and then they will stroke that same finger across its top 10 times, and then the other side of the finger 10 times, and then the face of the finger 10 times, and then the nail 10 times, and then proceed to the next finger. And you can imagine why they follow a ritual like this. They want to make sure their hands are clean, that all the bacteria have been removed. But notice that there are arbitrary elements here. Is 10 the right number? Could it be 8? Should it be 12? Do they have to divide their finger into the 4 quadrants? Or could they just do it with 3 quadrants? There's this element of arbitrariness. And that's also true of test-driven development. It's true of all disciplines. All disciplines have this essential nature, got to get your hands clean, but there's also this arbitrary element, 10 times. So, test-driven development. I have broken test-driven development up into 3 laws, and those 3 laws are somewhat arbitrary, but I believe they define the discipline pretty well. These 3 laws seem stupid to most developers. If you've been a developer for any length of time and you start looking at these 3 laws, you'd think, well, that's nuts. I don't want to do that. And as an example, let me quote you the first law. The first law of test-driven development says that you are not allowed to write any production code unless it is to make a failing unit test pass, which means you must first write a unit test, and that unit test must fail before you can write any production code. Now, right away, this just sounds dumb. I mean, what are you supposed to test? There's no code there. How can you write a test for something if the something doesn't exist? So that's the first arbitrary thing in test-driven development, and it gets many developers put off. They think, I don't make any sense out of that. But the worst is yet to come, because the second law makes things much worse. It says you are not allowed to write more of a unit test than is sufficient to fail. As soon as the unit test fails, you have to stop writing it. You can't write the whole test. You have to stop writing it as soon as it fails. And oh, by the way, failure to compile is failing. So the instant the unit test doesn't compile properly, you have to stop writing it and start writing production code. Now, since there is no production code to begin with, the unit test is probably not going to compile very quickly. You're going to type two or three words. You may not even finish an entire line, and you'll see a compiler error, and you have to stop and start writing production code. So this is much worse than just the first law. And if you're a developer, you think, well, how am I going to get anything done if I'm going to write a couple of characters of a test and then have to switch and write a couple of characters of production code? But then the third law kicks in, and it's the worst of them all. And it says you are not allowed to write any more production code than is sufficient to pass the currently failing test. Now, this is going to lock you into a cycle that is 5 seconds long. You will have to write a unit test first because the first law says you have to, but you're not going to be able to write much of it because it won't compile. So then you'll have to write some production code, but you can't write much of that because that'll make the unit test compile. So you'll have to go back to the test and add a little bit more to that, and that won't work because it won't compile again. You'll have to go back to the production code, and you're going to be switching back between these two streams of code on a 5 second by 5 second basis. And most developers, especially if they have a lot of experience, think of that as being crazy, stupid, boring, tedious. I mean, you would never be able to finish an if statement or a while statement. You'd never be able to complete your thought. You would always be interrupting yourself. And that's a reasonable way to think about it. It does sound goofy. It, by the way, sounds just as goofy to senior developers nowadays as washing hands sounded to doctors in the early 1800s. Because back in those days, no one understood germ theory, and the idea of washing your hands seemed silly, stupid, boring, tedious, a time waster. Took a very long time for surgeons to realize that cleaning their hands was actually kind of important. So, what if a group of us followed these 3 laws? What would happen? What if we had a room full of people and those people were following these 3 laws? What would you observe about that room full of people? Walk through that room. Pick any one of the people in that room following the 3 laws. Doesn't matter who you pick, and it doesn't matter when you pick them. Everything they were working on executed and passed all its tests within the last minute. And it doesn't matter who you pick, and it doesn't matter when you pick them. Within the last minute, everything they were working on executed and passed all its tests. What would your life be like if a minute ago everything worked? And this was always true. It was always true that everything worked a minute ago. What would your life be like? How much debugging would you do if everything worked a minute ago? And the answer to that is fairly clear. You wouldn't do an awful lot of debugging if everything worked a minute ago. There's not a lot to debug in a minute's worth of coding. In fact, the most common debugging technique amongst test-driven developers is to hit Control-Z enough times to make the test pass again, and then to rewrite the code you just wrote. How many of you are good at the debugger? How many of you have the hotkeys in your fingers, the debug foo in your body? You know how to do breakpoints and step intos and step overs, and you can set breakpoints and watch points, and you can really debug. This is not a skill to be desired. You don't want to be good at the debugger. The only way you get good at the debugger is to spend a lot of time debugging. And I don't really want you to spend a lot of time debugging. So I want you to spend a lot of time coding. Now, do I use a debugger? Yes, I do. The one in IntelliJ is very nice. I use it all the time. But I don't use it for long periods of time. And I don't use it as a part of my daily coding exercise. The amount of time I spend in the debugger is very small. And usually it occurs when I've got some test that's failing and I don't exactly know why, and I set a breakpoint on the failing test and I step in a couple of times and it takes me right to the code and I see the fault immediately and go, oh yeah, okay, and I fix it. The amount of time I spend in the debugger is small enough that I can't remember which hotkeys are step over and step into. It's F7 and F8, but I don't remember which one is which. And I always have to hover over the little icon and remind myself. It's just not in my memory. That's the level of familiarity I think you want to have with the debugger is something that you are tentative about rather than something you are expert at. Now, I don't want to tell you that you don't ever use a debugger. I use a debugger, as I just said. And there are times when you have to do long, horrible debugging sequences because this is still software. It's still hard. Weird things still happen. But the incidence of that, if you are a test-driven developer, is much smaller than if you are not a test-driven developer. So I could tell you that you could cut your debug time by some factor, call it D for debug time. And I'm not even going to tell you what that factor is, just D. Does this time that you are saving by not debugging make up for the cost and the silliness of the three laws? Hold that thought because there's something else to consider. How many of you have integrated a third-party package? Most of us have, and when you integrate a third-party package, you have to get it from somewhere. It's probably a zip file or something. You get this zip file and you unpack it, and sure enough, in the zip file, there's some directories that have libraries in them. Maybe it's class files, or maybe it's jar files, or maybe it's even source code. Somewhere in that directory structure, there's going to be a PDF, a manual, written by a tech writer that describes the way that this module works and how to integrate it. And at the back end of this PDF manual, there's an ugly appendix that contains all the code examples. Where's the first place you go? Well, you're a programmer. You don't want to read what the tech writer wrote. You want to see the code. So you probably go right to the end of the manual, find the code examples, and read them and understand them, and that's how you learn how to integrate the third-party package. When you are following the three laws of test-driven development, what you will produce in the unit tests are the code examples for the entire system. The same ones that you would have gone to at the back end of that PDF, the code examples for the whole system. That's what unit tests are. They are little snippets of code that explain how certain parts of the system work. And because you're doing test-driven development, there is a snippet in there that explains how every part of the system works. And these unit tests do not know about each other. They are not interconnected. Unit tests do not form a system. They are independent little units of code that reach into the production code and exercise a very limited part of it. And therefore, they are easy to read and easy to understand. And if you want to know how to work some part of the production code, there's a unit test that will tell you exactly what to do. Exactly how to call the functions, what arguments to call, what exceptions to catch. If you want to know how to create some object, there's a unit test in there somewhere, probably a set of unit tests that create that object every way it can be created. And these documents that describe how to work the system, because that's what these tests are, they're little documents, are written in a language that you are intimately familiar with, very comfortable with. That language is so formal it executes, it's utterly unambiguous, and it can't get out of sync with the production code. It is the perfect kind of low-level documentation. It's code, and that's what programmers want to read. So if you follow these three stupid laws, you will inevitably produce a stream of documentation that covers the entire body of the production code in a perfect way for developers to interpret. Now, does that make it worth to follow these three laws? Well, hold on, because there's another thing to consider. Probably many of you have written unit tests after the fact. And if you have, because it's the most common way of writing unit tests nowadays, if you have, you probably also discovered that it's not a lot of fun. And why isn't it fun? Why isn't it fun to write unit tests after the fact? And the answer to that is pretty simple. You already know the code works. You already know the code works because you've tested it manually. And now you have to write a bunch of unit tests after the fact, which seems like a waste of time because you already know the code works. But you're supposed to do it because some process person said, oh, yes, you must write unit tests. And so you kind of half-heartedly go in and write a unit test here and a unit test there. And you look at the unit test, it sort of works. You do another unit test, that one works too. Inevitably, however, you will come to the code that's hard to test. It's hard to test because you did not design it to be testable. And the effort required to make it testable seems too large. And you look at your watch and you say, oh, heavens, I've got other things I've got to do, and I already know this works. I don't feel like spending the time in making this function testable, and you walk away, leaving a hole in the test suite. And you know that if you leave such holes in the test suite, so do other people. So you look at the rest of the team and you realize the rest of the team is also leaving holes in the test suite, and therefore the test suite is full of holes. Now, what is the result of a test suite that's full of holes? When you run a test suite that's full of holes, if that test suite passes, it tells you nothing. It does not tell you that the system works. There is no decision you can make if that test suite passes. If it fails, it tells you something. Something you tested broke, and that's valuable. But if the test suite passes, it tells you nothing. And of course, you always want it passing, so it constantly tells you nothing. You don't trust the test suite. How many of you have had this experience that you run the test suite, you see it pass, and then you kind of smirk to yourself and say, yeah, it passed. And you know that there's no action you can take just because it passed. Something different happens when you write your tests first. When you write your tests first of all, it's fun. And why is it fun? Well, it's fun because you write something that doesn't work and then you make it work. And most of us programmers got into this business because once in our very young lives, we wrote something that didn't work and then we made it work and we felt the power. And we want that power and that feeling again of constantly making things working. Every time you write a little unit test and you see it fail and then you make it pass, you get this little jolt of, oh yes, I'm a programmer feeling. So it's fun, or at least more fun than writing tests after the fact, but there's something else. If you write the test first, it is impossible to write the function that's hard to test. You can't write the function that's hard to test because you wrote the test first. You have to design all of your functions to be easy to test because you're writing the test first. And a function that is easy to test has another attribute. The reason it's easy to test is because it's decoupled. That's what it means to be easy to test. Something is easy to test if it's not coupled strongly into the rest of the system. So by writing the tests first, it's fun, but you also produce production code that is much less coupled. You will decouple it in ways that you never thought you would decouple it. But then something else happens. And this is the real reason that we do test-driven development. I'm about to tell you what that is. All that other stuff, the fact that you reduce your debug time and the fact that you produce documentation and the fact that you produce better code and it's fun, all of that stuff is fine, it's good, we like it. But the real reason that we do test-driven development is because if you do test-driven development and your test suite has been produced by test-driven development, then when the tests pass, it means something. It means that the system works. It means that you can ship, you can deploy. And that's really the goal of test-driven development. The goal of test-driven development is to create a test suite that when it passes, tells you that you can deploy. There's nothing left to do. There's no other tests that need to be run. You are ready to deploy because the test suite runs. How many of you have looked at your screen and seen bad code there and had that bad code slow you down? How many of you have been slowed down by code that is a mess? And at this point, you're all nodding and saying, well, yeah, I have. And if you haven't, then either you're not a programmer or you're lying to yourself, because we have all been slowed down by bad code. The question then is, why did we write it? Why did we write this code that's bad? And the answer to that has a number of interesting factors to it. Number one, we often write bad code because we're in a hurry. We're in a rush. We've got deadlines. We have to go fast. And so we write the thing that slows us down in order to go fast. I will leave you to deal with the logical inconsistency of that. There's another reason why we write bad code, and that's because it's impossible to write good code at first. We're so focused on getting the problem solved that we solve the problem by virtually any means, leaving a mess in our wake, and then we do not go back and clean it up. Why don't we go back and clean it up? Well, for one thing, it'd take a lot of time, and we don't have that time. We've got deadlines. But there's another factor, a much worse factor. How many of you have brought code up on your screen? You look at it and you think, oh, God, this is a mess. I should clean it. And your very next thought is, I'm not touching it. Because you know if you touch it, you will break it. And if you break it, it becomes yours. So you walk away, not cleaning the code. I submit to you that if that is your reaction, if you respond that way to the messy code on your screen, then the only thing that can ever happen to that code is that it will rot. It will get worse and worse and worse over time, because no one can clean it. Everyone backs away. And so the only thing you will ever do to it, even though you're adding features and fixing bugs, you will do so in a way that preserves your own safety, not the cleanliness of the code. You will respond in fear, and you will rot that code, and it will get worse and worse with time. And as it gets worse and worse with time, the whole team slows down, because that bad code slows everyone down, until you finally get to the point where the code is so bad and so awful that all the developers are demanding that the whole thing be redesigned. But what if you had a test suite that you trust? A test suite that covers everything. A test suite that when you run it and it passes, you feel confident you can deploy. Then you bring bad code up on your screen and you look at that bad code, and your first thought is, I should clean it. And your next thought is, I bet I could change the name of that variable right there. And you do, and you run the test suite, and oh, it passed. By the way, that test suite's going to have to run fast. So then you say, oh, that function's too large. I think I'll split that function in two. That'll clean it up a little bit. You run the test. Oh, it passes. And then you say, oh, I'm going to take that function down there. I'm going to move it to a different class. And you run the test suite. And it fails, and you put that function back. And you realize what you did, and you do it the right way, and it passes. This is the way we want you to behave. We want you to have control over the source code. We want you to be able to reach into that source code and clean it on a whim without a second thought. And the reason you can do that is because you have that test suite. And that test suite runs fast. And the result of that test suite, when it passes, allows you to make decisions. Decisions like, I will clean the code.